For a long, long time, understanding the history of language has been a bit like archaeology, right? You find these fragments, ancient texts, words that sound similar, little grammatical clues, and you try to piece together the whole story. But what if you had a new tool in your kit? Something that doesn't just connect the dots, but actually tells you the probability that your connections are right? Well, this is where statistics crashes into ancient history, and it is fascinating. So let's get into it.
So this is the big one, the central mystery we're trying to solve. It's one thing to look at the English word father and the Latin word pater and go, yeah, those look related. But it's a whole other ballgame to scientifically trace their journey back in time, to estimate when they split apart, and to do all of that with real mathematical confidence. This isn't just some abstract puzzle. It's a fundamental question about our own human story.
And for centuries, the approach was brilliant, but man, was it painstaking. Linguists played detective, meticulously comparing words, sound changes, and grammar to build these huge language family trees. But there was always this lingering uncertainty. How could you be absolutely sure a similarity wasn't just a wild coincidence, or maybe two cultures just borrowed words from each other? You had to make these highly educated guesses, but that hard, numerical proof, that was often the missing piece.
And right here, this is where the game completely changes. Imagine going from a world of, well, this seems pretty likely, to a world where you can say, there is a 95% probability that this hypothesis is correct. This massive shift, this ability to actually quantify our uncertainty and measure our belief in the theory based on hard evidence is at the heart of a statistical revolution that is quietly remaking the entire field of linguistics.
Researchers are calling this the quantitative turn. And it makes sense, right? We now have these massive digital libraries, huge collections of text, and computers powerful enough to crunch all that data. So, of course, our methods for analyzing it all have gotten way more sophisticated. And in just the last few years, one particular statistical approach has been gaining some serious momentum, moving from the fringes right into the mainstream.
So, check this out. This chart shows something pretty remarkable. This isn't some slow and steady trend. We're talking about a huge jump in just 5 years. The orange bar there, that represents papers using these Bayesian methods. It goes from being just a tiny sliver in 2019 to a really substantial piece of the pie by 2024. This isn't just some new fad, you guys. This signals a fundamental shift in how linguists are even thinking about evidence. It's no wonder they're calling it a Bayesian Dawn.
Okay, so we've established that it's getting super popular. But what is Bayesian inference anyway? Well, at its core, the idea is actually incredibly intuitive. It's just a formal mathematical way of doing what our brains do all the time. We update our beliefs about something as soon as we get new evidence.
And this is the crucial part right here. Probability isn't seen as some fixed, unchangeable law of the universe. Instead, it's treated as our degree of belief or our confidence in a statement. And that is so powerful because it lets us say things like, the probability that this theory is true is 90%. That's a much more direct and, frankly, a much more useful way to talk about scientific results.
So here's the philosophical split. On the left, you have frequentist statistics. That's probably what most of us learned in school. It defines probability by, how often something happens over a million tries. Its main goal is often just to prove a null hypothesis wrong, basically to say, yes, there is an effect, or no, there isn't. But the Bayesian approach on the right is different. It gives you a full range of plausible answers and tells you how confident you can be in them. It's not just a simple yes or no, it's a here's what's most likely and here's our confidence level.
Let's make this super simple with a coin flip. Okay, step 1. You start with a prior belief. Before you even flip the coin, you figure it's probably fair, right? A 50-50 chance. Step 2, you gather new data. You flip it 20 times, and whoa, you get 15 heads. That's unexpected. That's your evidence. So in step 3, the process combines your initial belief with this new data to create an updated posterior belief. Now you're thinking, okay, given what I just saw, it's actually much more likely this coin is biased. And that's it. You've just done Bayesian inference.
So, that's the theory. But how does updating our belief about a coin flip help us trace the history of an ancient word? Well, let's see how this exact same process scales up, from a simple coin toss to reconstructing the deep, deep history of human language.
Okay, this is one of the coolest applications. By treating super basic words, like for one, two, hand, or eye, as if they're inherited genetic traits, these models can build incredibly detailed language family trees. But they don't stop there. They can even estimate the dates when different languages split off from a common ancestor. This gives us a timeline with probabilities for ancient human migrations. And this stuff is being used right now to tackle these massive, century-old debates, like figuring out where the entire Indo-European language family actually began.
Another really powerful use is something called keyness analysis. The goal is pretty straightforward. Find words that show up way more often in a specific text, say a legal document, compared to a huge general collection of texts. It's all about finding the unique lexical fingerprint of a document, whether it's legal jargon, scientific papers, or even just the unique style of a single author.
And this is what it looks like when you put it to work. Instead of just getting a simple word count, the analysis gives you this number called a Bayes factor. Just think of it as a score for the strength of the evidence. It tells you how certain you can be that a word is truly key to this text. So if you look at this table, where it's like IFRS, which is an accounting standard, directors, and remuneration all have these massive Bayes factors. The interpretation? Very strong evidence. It's basically screaming at you that you're looking at some kind of corporate or financial report. We're moving way beyond just counting words to actually measuring their statistical importance.
So, we can build family trees, we can find textual fingerprints, but what about the life of a single word? How do its meanings morph and change over time? Well, the title of this 2016 paper points us to the next big frontier, modeling diachronic meaning change, which is just a fancy way of saying how word meanings evolve through history. Think about a word like broadcast. Originally, it literally meant to scatter seeds by hand. Now, of course, it means transmitting a TV or radio signal. These Bayesian models can actually track this semantic shift automatically. They sift through millions of sentences from different decades, and they can spot when a word starts showing up in new neighborhoods, surrounded by new words. It can pinpoint the exact moment a new meaning starts to take hold. It's like watching the birth of a new meaning in slow motion, all captured in the data.
So, when you put it all together, this is way more than just a nerdy software update for a small corner of academia. The rise of Bayesian methods really represents a more transparent, more intuitive, and just a more powerful way of reasoning with data. It's all about being honest about our uncertainty and then systematically updating what we know as we learn more. So why are so many researchers getting so excited about this? Well, first, it's incredibly flexible. Language is messy, right? It doesn't fit into a neat little box, and this method can handle that. Second, the results are really intuitive. You get a direct probability that your theory is correct. Third, it quantifies evidence. It doesn't just tell you there's an effect, it tells you how strong that effect is. And finally, it's super transparent. You have to state your prior beliefs up front, which puts all your assumptions on the table for everyone to see and debate.
And all of this brings us to one last really powerful question. For pretty much the first time, we have the tools to map the evolution of human culture, as it's written in our language with a whole new level of scientific precision. So if we can see exactly how words and meanings changed in the past, what does that tell us about the changes happening right now, online, and real time? What new meanings are being born as we speak? Now that is the next great mystery these amazing tools could help us solve.